Good afternoon. I'm Lauren Clisby from TNO, here to talk about Tulipa Energy Model, which is open source energy system optimization in Julia. And it's really a dream collaboration between TNO, the Netherlands eScience Center, and the universities TU Delft and Utrecht University. At TNO, we're sort of the bridge between academic research and industry in the Netherlands. So we publish, but we also advise the government and work with industry to bring science into the real world. In my department, we work in the energy transition from fossil fuels to sustainable energy through analyses, policy, advice, things like that. And the really big problems that we're looking at with energy transition is having variable supply. So you can't control when the wind blows, when the sun shines. Electrification, a lot of industries are going from things that burn to trying to electrify everything, electric cars, for instance. So we have growing demand. Grid capacity is already an issue in some places, and when you electrify everything, and also when you change from centralized production to decentralized production, you need a new grid. And reliability of the system, especially if you go to a lot of solar and wind, then what happens if the wind doesn't blow for 2 weeks? What happens to your system? So we have a lot of things that we're juggling, and in my department, we do this with energy system optimization. So just very quickly, we have two problems that we're solving. The investment problem, which is how should we build up the system for the future? So where do we need to add more production? How do we need to build up the grid? And how can we do that for the minimum cost? And if you give, if you look at a future system, how will that system operate? So then you can see the usage of the different assets, how the grid is being used, where energy is being produced and stored, etc. And you can also give it different scenarios and see the outcomes. And the normal way that we do analyses is to have sort of a most expected future scenario, and then what happens if, so what if cases of what if we apply this policy, what if we change the price of CO2, what if, we don't have wind for 2 weeks, what happens to the system, things like that. So there are a lot of existing models that do energy system optimization. We have several at TNO, but there's lots of them. And you have one of two models currently. So you either have a smaller scale, very detailed model. So maybe it's only for electricity, or it's electricity with some gas, or it's just for a certain geographical scope, but it doesn't include the full, all of Europe. Or you have a large scale model, so it's a European model, but then it can't include that much detail because otherwise the problem, basically you're running into computational limitations. So then you simplify either in the details of the technologies or in the grid detail, or not having a grid at all. Or most likely you reduce the time resolution of your optimization, your dispatch optimization. So you don't see what's happening in the system every hour, but you see what happens every 2 to 3 to 4 hours, depending on how big your problem is. But this really loses a lot of critical information that you need for these analyses because the electricity market is hourly. So if you start aggregating up, then you lose these like big peaks that are the things that you need to be accounting for. So at TNO, we thought there's a better way. We knew that if we could produce better formulations themselves and really look at the reducing the complexity of the problem to solve faster, then we could get a lot of gains. And we called on the universities to help us with the research. We had some ideas, but we needed to flesh it out a lot more. So one way that we do this, we're working in mixed integer linear programming. I think we had some talks about this earlier today. So and those problems, mixed integer problems, grow exponentially with this, or the solving time grows exponentially with the size of the problem. So if you just look at this very tiny example, then your feasible solution space for the integer problem are all of the dark blue dots. But because it grows exponentially, we actually use linear approximations. So now the gray area is everything is feasible. But that means that you could get a gray solution that's not actually the solution to the original problem. So then you have to adjust it until it actually is what you're looking for. But there are infinite ways of formulating this gray area for any given integer problem, and they're not all equal. So tight formulations reduce the size of the feasible region, and they usually increase the number of constraints. So you're shrinking the area that the solver has to search in order to find the actual solution. So it will solve faster. But there's also compact formulations, and they use fewer constraints. So this also is a simplification. And what you really want is to be tight and compact. So that's using as few constraints as you can with the smallest feasible space for the linear approximation of the integer problem. These are the type of formulations that we're really looking for, and we found several of them, but we're still looking for it for each of the different pieces of the model that we're doing. Another thing that we do is we give the power to the analyst to use mixed levels of detail. So instead of a lot of current models make assumptions about, like, you can only look at this geographical scope, or you can only use this type of this level of resolution. So we enable the analyst to choose their geographical resolution. So you can say, I want more detail in the country that I'm looking at, but more assets and more exchanges and things. Technological detail. So we actually have multiple formulations for the same behavior of technologies. So maybe, for instance, if you look at unit commitment, you can have a very simple formulation, and then you can have more complex formulations, and you can mix them in the same model to say, the place I'm looking at, I really want this behavior to be very specific, but I still want these other assets to do it, but less specifically. And most importantly, we have flexible temporal detail, which is the time resolution of the model. Like I said, you need to be solving hourly for your operations to see what's happening, but that's specifically for electricity, and maybe you don't care about it. You don't really need it if you're looking at, like, gas or hydrogen. So if you have a system with a bunch of different things happening, you want the detail where you need it and not where you don't, because this is the largest dimension that we're dealing with our problems. So any savings you can have in your time dimension is huge. So for instance, this is if you use, rather than having, say, hourly resolution for all of Europe, you have hourly resolution in your country of interest, for us, the Netherlands, 2-hourly resolution for all of its neighbors, and 3 and 4 and 5 out from there. This will introduce quite a lot of error for your solution in Portugal, but you're not looking at Portugal, you're looking at the Netherlands. So this is, in this example, the blue line is if the entire system is on hourly, 2-hourly, 3-hourly, 4-hourly. The speed is the y-axis, and the x is then how much error you're introducing with the simplification. So the orange dot is showing that with this technique, you can solve significantly faster and also with less error than just changing from 1-hourly to 2-hourly. So it's really, really powerful. And we actually do it now where you have the neighbors also in hourly. But this is just geographical. You can also do it by energy carrier type. So keeping electricity on hourly and changing gas and hydrogen, things like that, and heat. So what do we get from this? Well, those are just two things, but basically some of the things that we can do is we can solve the same problems that we were solving before, but faster and with less computational burden, which also means that we can start solving bigger problems with more detail, etc. We can actually improve the accuracy without adding extra computational burden. So this is huge because, yeah, we're dealing with computational burden, but for instance, oh, I didn't actually cover that method, but this is just another thing that we can do. Sorry that I'm not explaining it very well. And we can, mostly through mixed detail, that we give the analyst the power to balance burden and accuracy for the analysis that they're doing. So in my country of interest, I want high detail, but I still want to include the rest of Europe. I'm looking specifically at electricity. I need high detail there. Or I'm looking, whatever you're doing, it's up to you. It's not an assumption of the model. So we have the research. Ooh. Okay. We have the research, but we still need to apply it. And we looked around and we're considering applying this to existing models, but we realized that some of the research was so fundamental that you would have to refactor from scratch, especially with the flexible time resolution that kind of changes every formulation in the model. So then we decided to implement from scratch and started looking around. And luckily, the Netherlands eScience Center was working with us. So they are a group of, or an organization of research software engineers, and they work with universities and also research organizations to help researchers do better code, because we don't code very well. Generally, we're more interested in the math, and they're helping us with the implementation. So some of the things that they've really helped us with are choosing our language. We chose Julia because we're researchers, so we need friendliness, but we're also going for performance, both in memory and speed. And also because of JUMP, which was the previous talk. So you heard a lot of the great things about JUMP. It makes building the model quite easy and friendly. They helped us a lot with coding best practices, which for software engineers are probably pretty self-evident, but anyone who's worked in academics maybe knows that these aren't always present in your research work. So they helped us get started and set up and keeping our documentation going and using a healthy workflow so that we do code reviews, things like that. Our license is Apache 2.0. And this actually inspired the creation of BestieTemplate.jl, which is a package template for Julia packages, and it is opinionated, but it has a lot of useful things if you're creating new packages a lot, or if you're working with people who aren't used to using best practices. The creator, Abel Sequeira, is in the front row if you have any questions. They helped us realize when to create a new repository and not do everything in one. And some of these are still work in progress. These are not all complete, but we now sort of have an ecosystem of packages rather than just one mega package. And we even created near optimal alternatives and didn't brand it as Tulipa because it's a generalized package that is just doing a post-optimization method for using like modeling to generate alternatives, things like that. They also helped us make the decision to use DuckDB. So because we're working with researchers and individuals, we wanted something that's quite portable. It doesn't require a server. You can query files without using import, which is nice because a lot of people are using Excel. It has wide language support, so we don't force them to use too much Julia. They can actually do their pre and post processing in whatever language or method that they feel like. And it is columnar processing rather than row, which our data is pretty static, so that makes sense for us. Also, we originally made the choice just for DuckDB in order to ingest our data, but now we use it as a backend for JUMP for data handling, and Abel has a poster on that if you want to go see more about that. So where are we now? We just released version 0.18. It's open source. You can go use it, package add TulipaEnergyModel. We're still in heavy development though, so more features on the way. We currently have a lot of features. The bottom two are what we're currently working on, and these are features that a lot of other models also have, but we have these are what are feeding our publications. So a lot of these are novel formulations that we developed that are faster, more efficient, etc. We have our first few case studies, so people are actually using the model, and we're getting feedback and seeing how it's being used and what projects we can use it in. We've started a learning community, so if you're in energy system modeling and you want to use Tulipa, contact me. We're doing a learning community that it's free, and we're just trying to get feedback from new users and teach people, which is actually One challenge is that Tulipa is very generalized, and we also have different levels of users. So some people are coming from other models. Then we have to explain in Tulipa terms of how to model what they're used to. And then some people are more beginner in energy modeling. So we're also giving a crash course in energy system modeling. And then Tulipa is also it's the model itself, and it doesn't include much of the friendliness around it. So user interface, graphics, those kind of things we don't really have. So it's also a challenge to teach people how to do stuff very manually. Here's the whole team. These are all the main people who have been involved so far. The core team of Germán, Abel, Ni, Diego, Suvayo, and I are in the center. Then we also have our postdoc, PhDs, master's students who have done a lot of the main mathematics of the constraints and features. And then we have some early users on the outer rim. I think we actually have some more people who are involved now because we have new students getting involved. But it's a growing project. That's all I have. Questions from the audience? Thank you.
Thank you for the presentation. So beginning of this week, the European markets moved from 1 hour to 15-minute market time units. So I was just curious, how does that affect your modeling effort? Does it complicate things a lot?
It will increase the size of whatever problem that you're modeling, but we actually don't make an assumption of hourly as the smallest granularity that you can use. It's generalized, so we just treat it as a time step. So this is actually something that we maybe can do that other models maybe can't even do. We don't know. It will make the size of your problem a lot larger, but depending on what you're looking at, you can use different methods that we have of making it still tractable. And also, yeah, that's just electricity and probably your area of interest. So then same map, but 15 minutes and then out from there. So we haven't run a case with 15-minute yet, but yeah, it would be really cool to see.
Hi, thanks for the presentation. The learning community sounded really cool. And I was wondering, there's also, you said people who are new to Julia as well. And maybe you can share something about what new Julia users are facing and things that are good and things that could go better.
Well, for us, it's quite difficult because we have a really broad range of skill level. So some people are maybe more used to using Python, and then we say, yeah, okay. Also that you can do your pre and post in Python and then switch to Julia just for Tulipa. But then we also have a lot of people who are used to Excel, copy pasting until they have their data and then feeding that into some kind of UI and pushing some buttons and getting their results and then creating graphs in Excel again. So we're really trying to push them towards better, more efficient pipelines, but then also meeting them where they're at. So I think Julia, for those who are not afraid of code, is quite friendly. But there's some who, when you show them code, they try to take a step back. So yeah, it's tricky. And maybe notebooks would be a friendly way of doing that. Also that we use DuckDB, and then DuckDB is not as Julia friendly. It doesn't have like implicit like Julia connections. So then, or I don't know the exact term, but so when you're using it, it's very SQL looking. And then it's like, do you want to teach them SQL and teach them Julia? Yeah, it's becoming a lot. But we also don't want to really go to a UI though. Because then it's very, you sort of have to make a lot of assumptions and you're really obscuring what's happening. So we don't want to start doing everything for them and then have them not even really know what's going on. Or we have like a function that is populate with defaults. So they explicitly have to know that their data doesn't include the full problem, and then they have to apply the defaults because we don't want it just to be buried in the documentation. Oh, we assume it's hourly. Like, yeah, it's a hard trade-off between performance above everything and then friendliness.
Other questions? No?
Could have been so much more.
Don't be shy.
So I'm also European, in the other side of Europe, in Greece, where basically the end user experience versus the market is very weird. I feel that the financial products that are disguised as our bills are very complicated for the average person. And connecting to that, like who is your user? Like who is, like, I'm feeling that there is a European problem, like very far away from the Julia code, that we don't explain to the average European how the market works. And I don't think there are tools for my mom to understand, like, why is the price 800 euros today and 20 tomorrow? And at least in like where I live, you get some very expensive electricity and you expect the government like to react in some months. But it's really like some of these products would be illegal to buy if it was not energy. Like if it was futures on the American exchange, they would bar me from buying them. So my question is, who is the user? Like, who is that Excel person? And what can we do, maybe as a community, to bring that closer to my mom? My mom is a master of science, so she's not like the average, but like something like how can we make something for the public, basically, is the question. Because all of this is very complex, right?
Yeah, so this isn't that. It's not going to predict the prices of electricity tomorrow. It is more for policy advice and long-term investment decisions. So it's for the grid operators, for the government, for large investors, so people building wind parks. And our users are mostly, well, TNO, because we do a lot of informing and things, and maybe other energy system research / consultancy people, or maybe a sort of government policy organization if they have technical analytics people. For what you're talking about, then you would need something, much friendlier. And there are sort of simulation type software where you could make some sort of online UI thing, but this is really optimization. There's like a web-based, I can tell you about one, but it's more used by government officials. But yeah, I think for that, you maybe wouldn't even need a really accurate calculation, but maybe just more of like an interactive thing that sort of shows where energy prices come from. Just like a learning tool that says like, oh, but look what happens when we don't invest in this, and then in 5 years, your energy prices do this, or things like that, just like an explainer of like where energy prices come from. But that is something, sort of step back, is that we get questions of like, is this going to be used? When people sort of are almost clients get excited about it, they say, but then can you make a UI where I can click around and see a bunch of results and things? And then we say, well, no, you kind of need to be a professional in order to use it in the first place. And then also optimization takes hours to solve. So then you're never going to get this like really interactive thing unless you do a bunch of runs ahead of time. Then you can go explore results, but different types of information. And that's also a good question. Conversation is how to explain to a policymaker what the results even mean. Yeah.
Has your model been applied to other countries than Netherlands? And if not, what does it need?
It is generalized where anything, you can use it for anywhere, just depends on what data you have. So we haven't used it for a country outside of the Netherlands, but that is completely just because of the projects that we do. We actually had a visit from an African country that just said, we're looking for an energy model. We said, well, it's open source, maybe you can use it. But they haven't started using it yet. But we just said, if you have, the thing is, if you have the data, you can use it for anywhere. Also at different scales, so you can use it for regional scale or international. We don't make any assumptions.
Yeah, thanks for a nice talk. I live in the Netherlands. I'm curious. You say your stakeholders, you're trying to influence politics by doing the research, how we can set up the power supply and distribution system. But there's also a lot of the public opinion you can influence, right? If you know how to basically bring your message. And in many aspects, climate change, and you name it, people themselves think, oh, what can I do? If I just use a little bit more, who cares? But it's the sun that cares a lot about it, right? Is that also something you have in scope? Because it's a tough challenge, right?
So TNO is independent and non-biased. So we have to be careful if we try to sway anybody. But our department is the techno-economic energy transition. So we focus on the industry and the grid, etc. But we actually have a sister department, the social economic energy transition. And they work much more at the local scale, teaching people about the energy transition, finding out how they feel about wind parks in their backyard, things like that. And also energy poverty is a really big topic. Trying in the energy transition to make it a fair transition and actually reduce the poverty gap rather than increase it. Because if rich people can buy electric cars, then you start having this like increasing gap.
So I understand that division, right? But still you can do the hard science here, the scenario play, and then you get, the best numbers out of it. And then how you wrap the message, okay, that's a separate storyline if you'd like, but you are doing the hard science, I kind of hope. Right?
Yeah, definitely. But we do present it in a non-biased way. We are definitely working with the government and trying to make it in a sustainable, a better future. But we currently aren't, at least in our team, we aren't presenting to the general public and trying to gain activism or anything.